Okay. So, so I'm going to talk about section 1.3, scientific measurement. I'm going to start off with the SI prefixes. Okay. Now, here are some of the more common ones. I'm going to start with smaller numbers, and I'm going to work my way up to larger numbers. So the first one is Femto, F-E-M-T-O, and it has a symbol. This is what's called a symbol, an F. And the femto is a really small number. I'm going to write it using exponential notation. We'll talk more about exponential notation later. But it's 10 to the minus 15, which is 0. I'm going to write 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1. That's a really small number, femto. Okay. The next one, this one is a little more common. We use it in chemistry even more than femto, is Pico. And it's also a very small number. It's a lowercase p, just so you know. And it's 10 to the negative 12. And so that one is 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then a 1. Okay, Pico. When we talk about the sizes of atoms, often we quote them in terms of picometers. The size of a nucleus of an atom is even smaller. That would be in terms of femtometers. Then we have nano. This one's even more common. You'll see this a lot in chemistry 11. Lowercase n, I'm sorry, that's an n, 10 to the negative 9. So that's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then a 1. Then we have micro. And the symbol here, by the way, this is an N, just so you're clear. This is called a mu. I'm going to write this underneath it. Mu. Kind of weird. It's a Greek letter. 10 to the minus 6. So I'm going to put 5 zeros. 1, 2, 3, 4, 5, and then a 1. And then we have milli. Milli is used in volumes quite a bit. Small m, 10 to the minus 3, 0.001. Okay. And then we have centi, lowercase c, 10 to the minus 2, 0.01. Okay, let me just make sure I've got the chat up here just in case someone. Okay, good. By the way, thank you, Nacha, for pointing out that I would have gone the whole hour. And then we have Deci, lowercase d, which is 10 to the minus 1, and that's 0.1. Okay, so these are just letters or words that represent numbers. So just like 1,000 is 1000, right? We use these prefixes to represent numbers. Okay. So that's from really, really small numbers, like the size of a nucleus, to the size of an atom, to the size of a large molecule, all the way down to the size of, all the way up to the size of a pencil. A pencil is in decimeters, okay? So those are the smaller ones. Now I'm going to look at some of the bigger ones, okay, the larger ones. Okay, so these are all small. These are all less than 1, right? Every number in there is less than 1. Now we're going to look at the ones that are greater than 1. And the first one that I'm going to put up here is, there are others, by the way. There's deca and hecta. To be honest with you, we don't use them in chemistry very often. You might use them in other areas, but I'm just going to go to the ones that we use in chemistry. Kilo, very common. K. Lowercase k, 10 to the 3. Kilo is another way of saying 1,000. Kilo is 1,000, okay? Oops. The next one is mega, which is uppercase M. So notice lowercase m is milli, which is small. And we all know the word milli usually means small. Mega is big, right? So mega 10 to the 6th. It's a million. In fact, I'll put commas here. For those of you from Europe or other parts of the world, I'm going to use the comma to mean powers of 1,000. And I'll use a point to represent fractions, okay? And you get the mega, and then the next one's giga, uppercase G, 10 to the 9, and then it's a billion. Really, a giga is a billion. So there's a million, and there's a billion. Cool, right? And then the last one I'm going to go over is tera. T-E-R-A, capital T, 10 to the 12, and then that's a trillion. So there's a billion, and then there's a trillion, okay? So these are different ways of representing a number. 1,000 can be represented by saying kilo, or 10 to the 3, or K. K would mean kilo as well. Okay, these are the ones that are greater than 1, and there are other prefixes out there. Like if you go on to Wikipedia and you type in metric prefixes or SI prefixes, by the way, SI just means System International. System International. Okay, you'll find that there's other prefixes out there. There's 10 to the 15, 10 to the 18, 10 to the 21, 24. I think it even goes up to 10 to the 30 now. And it goes all the way down to like 10 to the minus 27, I think. Very, very small, maybe 10 to the minus 30, okay? So smaller than 1, larger than 1, okay? Those are the prefixes. More commonly, you're gonna see problems when you do ALEKS. You're gonna see problems where they just give you the prefix, the symbol, and then you have to know that that means that, or they'll give you C, and you need to know that that means that, or you know, or in exponential notation too. Okay, so that's just like a little introduction into these prefixes. So let me show you a problem then, and then I'm going to show you how to do some of these conversions. So the first one, this problem on ALEKS is called understanding the purpose of SI prefixes. And they're going to give you a little table, and they want you to complete the table. So I'm going to take a look at an example here. So we have 200 CG equals how many G? The next one is how many kg, I'm sorry, km equals 7,000 m. The third one is how many capital M, capital L equals 5 million L for liters. And then 4,000 ms equals how many s? Okay, so as I go through this, I do want to talk a little bit about the units and how they relate to the prefixes and the numbers and all of that here, just to kind of get you used to thinking about units. When we make measurements, so the term measurement typically involves the following: a number, 50, for example. And then it has a unit, okay? A unit is, what is it you're trying to measure? Are you trying to measure length? Are you trying to measure time? Are you trying to measure mass? Are you trying to measure volume? What is it that you're trying to measure? So the unit, it could be a unit of mass. It could be a unit of time. It could be a unit of volume. It could be a unit of distance or length. Okay, and there's other things that it could be as well, but those are just 4 things that it could be. Okay, now typically what happens is we want the number to be not too big and not too small. Okay, so for example, if I said, how many atoms are in a fingernail, we might want to have a number that we could give to people that doesn't sound so large. So for example, I mean, the actual number of atoms in a fingernail is huge, right? It's like 1 followed by 23 zeros. That's a hard number to say. Alternatively, if we said how big is one of those atoms, it's pretty small, so the number would be 0.00 with like 23 zeros. So the way we get out of having numbers that are too big or too small is we put a prefix right in front of the unit. Okay, so let me show you an example of that. 200 CG. So let's dissect that number. So this is just a number, right? 200 is just a number. This is the prefix right here, the C. And the C is centi. And remember I said it's 10 to the minus 2, which is 0.01. So that's the prefix. And then you've got the unit here. And one of the things that you'll practice working on is figuring out what the unit is from the symbol of the unit. So we're not there yet. We're going to get into this in another topic. But G is a unit of mass, and G is short for gram. Okay, so a G is a gram, and that's a unit of mass, how much mass something has. Okay, so let's do this conversion. So I'm going to take our 200 centigrams, CG for centigram, and they want to have it in grams. They just, essentially what they want you to do is to convert it to a number without the prefix. They want you to get rid of the C, the prefix C. So there are different ways to do this, and I'm going to show you a way to do this, but when you read through the explanation on ALEKS, you might find their explanation is different, or it might be similar, it might be different. That's okay. There's more than one way to do problems. And so here's how I'm going to do it. I'm going to say that centi is 0.01. Okay, that's what centi is. So 200 centi. So I'm going to write it as times 0.01. Okay, and then I'm going to write the unit. Okay, so here's the number, here's the prefix, and then here's the unit, right? So there's, in many values, you can see there's three parts of it: the number, the prefix, and then the unit. But what I've done here is I've substituted in the actual number for the prefix. Okay, now the trick is to figure out, what does that mean when you multiply by 0.01? What it means is you're going to, if you multiplied something by 1, you don't change it, right? 200 times 1 is 200. If you multiplied it by 0.1, that would make it 20, right? You would move the decimal point once to the left. So if I'm going to multiply by 0.01, I'm just going to move the decimal point over 2 places. And I'm going to get 2.00, and then put the unit G, right? So what I've done is I've taken a number that's in centigrams and I've converted it to a different unit, which is now in grams, okay? So what I did was I said centi is 0.01. So 200 centi would be 200 times 0.01. And then you leave the G in there for grams. And then you just multiply 200 by 0.01, and that'll give you 2.00. Okay, let's try the second one. Okay. I'm going to, let me just erase this. The second one, they want you to kind of go the reverse. In the second one, they give you the number, but they don't give you the prefix. They want you to find the number as a prefix. Okay, so how many kilometers is equal to 7,000 meters? Okay, now you maybe haven't remembered, you maybe haven't memorized the prefixes, but I know some of them anyway. So I know kilo, and just, you know, earlier we said kilo has the abbreviation K, and it's 1,000, right? Kilo's 1,000, okay? So now what we want to do is we want to go from 7,000 meters into kilometers, okay? So here's what I'm going to do. I'm going to say that 7,000 meters is equal to what? 7 times 1,000 meters, right? 7,000 is the same thing as 7 times 1,000. Well, 1,000 is kilo. That's what kilo is by definition. That's how we define the kilo. So that means that it's really just 7 K for kilo, M for meters. This is a length unit, meters. And so now you have 7 km. Okay, so that was 7. And then this one was 2.00. Okay, so see what I did? I said, look, oh, they want to have it in kilo. Okay, kilo, I looked that up, that's 1,000. So then I say, okay, well, I want to have it in thousands. So I took my 7,000 and I wrote it as 7 times 1,000. And I picked 1,000 because I knew I wanted to have kilo. So 7 times 1,000, 7 kilo. And then don't forget to put the unit in there. And in the ALEKS problem, they give you the unit. They put in km and m.
Oh.
But as you do these problems, you'll need to know what those are. Okay. So that's the second one. Let's try the third one.
Hello? Hello?
Okay. I'm going to go ahead and mute it. Because
Lê a changé, oui.
not a good idea.
Oh, vous parlez quoi le 7?
So if you do have a question about the class, just go ahead and unmute yourself. You can unmute yourself. Okay. All right, so the third one is let me bring the chat up here. I'm sorry, the third one is 5 million. So 5 million. And we want to know how many megaliters that is, okay? So it's got a capital M. So capital M is mega, and mega is a million. Okay, so there's a million. So then, okay, we want to have it in megaliters. This is a unit liters, by the way. Capital L. So what's 5 million in terms of millions? 5 million is 5 times a million. So that's 5 times a million liters. See, I bring the L down just so I don't lose track of what the unit is, okay? And then a million is mega, right? That's the definition of a mega. So that means that this would just be 5 capital M million capital L liters. Okay, so you got that one right there, 5 megaliters. And then the fourth one is how many kilometers is 7,000 meters? So I think I have room down here. So 7,000 meters equals how many, let me write this right down here. Oh, I'm sorry, what am I doing? I lost track of myself. Last one right here. 4,000 milliseconds. 4,000 ms equals how many s? Okay, so let's try this one. Now we've got milli, that's milli. is 0.001. Okay, so that's milli. So that means this is 4,000. And then what you do is you do times the prefix, times 0.001. And then you put the unit. Okay. So now you just say, okay, what happens when we take 4,000 and we multiply it by 0.001? Every time you multiply it by 0.1, you move the decimal place 1 point. If you multiply it by 0.01, you do it 2. If you do 0.001, you do it 3. So we're going to move it over 3 places. And that would give us 4.000. But now that would be in seconds, right? So I've taken our milliseconds and I've just converted it into seconds. So that would be 4.000 seconds. Okay. So that's based on the prefixes. Let me save this little slide here. And then come back over here, just so you can see them again. So these are all the prefixes, right? You got the femto, the pico, the nano, the micro, milli, centi, deci. So those are the ones that are less than 1. In that problem, we did use milli. And then we also use centi. And then there's the ones that are bigger than 1, which are the kilo, mega, giga, and tera. For that particular one, we used kilo and mega. And there you go. Those are the prefixes. They're kind of cool. So the whole idea, just to remind you again, is about making a number not be so big or so small. So look what happened when we did the first one. We went from a big number, 200, which quite frankly isn't that big. 200 is not that big of a number. But we took a number that's kind of large, 200, and we converted it into a smaller number, a number closer to 1. That's essentially what we're looking for, is to convert numbers to closer than 1. So 200 became 2 if you're in centigrams versus grams. 7, if you're in kilometers, so for example, if you had 7 kilometers, that would be a big number of meters. So when you have the prefix, generally the idea is the prefix is going to give you a number that's closer to 1. And then if it doesn't, if it's already a big number with the prefix, then you tend to want to get rid of the prefix just to have the number be closer to 1. So in each of these problems, really what we were doing was we were making numbers that were either, well, they were big, and converting them into smaller numbers, into numbers that are closer than 1. Okay. And that's sort of the idea behind the prefix, is just to get numbers closer to 1. So, you know, if you go into a gym, for example, and you see that you've got a, what would it be, 20 kilogram weight, which weighs around 45 pounds. Okay. So in a gym, those are those big, pretty big plates. They make bigger ones now. You got this big plate in the gym, 20 kilograms. Well, kilo's 1,000, right? So that's really 20,000 grams, right? Because if you take 20 times 1,000, that gives you 20,000. So they're not going to put 20,000 grams on there. They're going to put 20 kilograms because that's just an easier number to write. It's an easy, go get me a 20 kilogram weight. Don't get me a 20,000 kilogram weight, right? Or 20,000 gram weight. So that's the idea. We use the prefixes when we can in order to make the numbers more reasonable numbers. Okay. So like I said, you may find that the ALEKS conversion problems are a little different. They may do them differently than I did, and that's perfectly fine. You can look at both explanations and then decide which one you think is better. And if hearing 2 different ways of doing something ends up confusing you, then you can reach out to me and we'll go through it and figure out what to do about it, okay? Now let's talk a little bit about powers of 10. So the next ALEKS problem that I see here is they want you to start working with powers of 10. So let me just kind of move this over here a little bit. There we go. Okay, so this particular problem, I think I have some room here. Well, let me just erase this. This particular problem is called knowing the value of an SI prefix as a power of 10. Okay, so this ends up being kind of an important one. It's a pretty simple problem. It's not that complicated. You just look up the values, but it's important to understand this idea of powers of 10. So what they want you to do is to complete everything. So they give you one blank HZ. This is a different unit. It's called a hertz. Equals 10 to the minus 2 hertz. So HZ is frequency. That's something you'll talk about in Chem 1100. We don't really talk about it in this course. One capital M, HC. So these are all in hertz. Good. At least they're consistent. And then they want you to figure out what that number is there. And then 1 KHC equals 10 to the box HC. And then the last one is 1 blank HC. I guess I'll just put a box there, just so it's the same. That's what we're trying to find out, is what's in that box. 10 to the minus 6 hertz. Okay. So all you really need to do is just look these things up. You know, the previous, let me just save this one. The first slide right here, it shows all of them to you here. Just make sure that this is showing up. There we go. Yeah, they're all there. Okay, so there they are. There's all the prefixes, and I've shown them there as powers of 10. Okay, so a couple things to recognize is that when you're in the ones greater than 1, it starts at 3, then 6, then 9, then 12. And that's really 1 followed by that many zeros. So when I say 10 to the minus 9, or 10 to the 9, 10 to the 9 is 1 followed by 9 zeros. That's a billion. Mega, 1 followed by 6 zeros, right? So the exponent for the ones that are greater than 1, that exponent is equal to the number of zeros that follows the 1 there, okay? So let's take a look at this one. So 10 to the minus 2, looking that up in the chart, 10 to the minus 2, that's the same as centi. So that's a lowercase c. So the way this would be read is 1 centihertz. So you read the number, then you read the name of the prefix, and then you read the name of the unit. So as I said, hertz is a unit of frequency. So 1 centihertz. The second one, mega, right? That's a capital M, that's a mega. Mega is a million, mega million, right? So million, that's one of the easier ones. So million, 10 to the 6th, okay? So 6, 10 to the 6th. So we would write that as 1 megahertz is the same thing as 10 to the 6th hertz, okay? Because 10 to the 6th is mega. 1 kilohertz, right? K for kilo. 1 kilohertz, well, kilo is 10 to the 3rd. So that's a 3. I'm sorry, that's hard to see. Let me make that box a little bit bigger. There we go. 10 to the 3 hertz is the same thing as a kilohertz. If you listen to AM radio has frequencies that are in kilohertz. So I don't know if anybody listens to AM radio. I don't listen to it very often. But you know, you got your AM radio stations, and the lower end of the AM radios is 540, and it goes up to 1600. This is AM, not FM. FM is higher frequencies, okay? So those numbers refer to the frequencies of the signal that's going through the air, okay? So it's a wave, it has a frequency. And so these are in kilohertz, KHC. So 540 kilohertz. You know, so there's what, 770. In New York City, 770 is a big one. 820 is a big one. 880, 1010. There's other ones as well. But those are all in kilohertz. So that's right there. So 10 to the 3 kilohertz, that's 1,000 hertz, really. That's much smaller than these frequencies here. Okay. And then the last one, 10 to the minus 6, go to the table, look up the table. 10 to the minus 6 is micro. 10 to the minus 6 is micro. And the symbol for micro is a mu. Again, that one has the funny pronunciation because it's Greek. Well, funny to me anyways. It's mu. Okay. That's how I've learned how to pronounce it anyways. Okay. So 1 microhertz, we would use that symbol. Okay. If you're doing any kind of typing on Microsoft Word or word processing, typically if you put a little M and then you highlight that the M and then you change the font to symbol, it will often change it to a mu if you ever need to type that. Okay. The ALEKS homework assignment, you know, that software has symbols you can put in. You can just select the mu symbol for that one. Okay. So that's just giving you a little bit of practice, kind of using those prefixes and seeing what those numbers are used for. So if I said something is 10 to the minus 6, we would put micro. Okay. If you have questions as I go along, just let me know. Oops. Okay. Let's take a look at another one. Okay. So here's one a little bit more kind of like a real problem, not just sort of an exercise of doing little conversions. This is a real problem. So this one is called interconversion of prefixed and base SI units. Okay. So let's take a look here. In this one, they say that you have a cell biologist. So some biologist working on cells, right? And the cell biologist measures the width of a cell. Okay. And the width is 45 micrometers. 44 micrometers. And what's the width of the meat? What is the width? What is the width in meters? And with this one, they want you to write the answer in scientific notation. Okay, now that's an important point. I don't believe I put any ALEKS problems in your course specifically practicing scientific notation. So what I'm going to do is I'm going to talk about it right here, what scientific notation is. Scientific notation is a way of representing numbers. And the way you represent the number is you generally have a decimal number, like 1.3, that's a decimal number, where the number in front of the decimal point is 1 through 9. So not 11 point or 55 point or 3,000 point. It's usually, 1 point or 2 point, a number between 1 and 9, point something. I'll put an extra decimal number, okay, times 10 to the x. That's called scientific notation, okay? So if I just wrote 10 to the minus 4, that's not considered scientific notation. It is exponential notation, but it's not scientific notation. So the way I would make this scientific notation is I would just write 1 times 10 to the minus 4. Because remember, if you multiply something by 1, it doesn't change it. So writing it as 1 times 10 to the minus 4, that would be scientific notation. I'll abbreviate it, okay? Here's another example of something that's not scientific notation. So 1.5 times 10 to the 3.3, okay? Now that is a number between 1 and 9 times 10 to the x, but this has to be a whole number. That's a requirement of scientific notation. You can't have a decimal number in the exponent, the number up there, okay? So if I had 1.6 times 10 to the 4, that would be scientific notation, okay? If I had the number 11.6 times 10 to the 4, this would not be scientific notation. It's almost scientific notation, but it's not quite there. And the reason is this number in front of the decimal, it has to be between 1 and 9. So it could be 1.3, 4.7, 9.8, but it can't be more than, it can't be 10 or more. It can't be 11 or 10 point. It has to be between 1 and 9.999. So less than 10 times 10 to the x, and x has to be a whole number, okay? So let me erase that. And let's take a look at how we're going to do this problem. So this is a cell. It's a 44 micron cell. So it's most likely a eukaryotic cell. Prokaryotic cells are usually smaller than that. They're like a couple microns maybe. So it's probably not bacteria. Okay. 44. So here's the idea. Physically, what we're doing is we're saying, hey, you got this cell, right? You have this cell here. There's our little nucleus for the cell. That's where the DNA is. Got these little protein receptors on there. All that kind of stuff, right? Got your Golgi apparatus. Okay, so what they're saying is this is 44 micron, or 44, yeah, 44 microns across, okay? So that's a size, right? A meter is a unit of length, so a micrometer is also a unit of length, right? Okay, and so what we want to do is we just want to have it in essentially they're asking you to get rid of the prefix. Okay, just get rid of the prefix is really what they're asking. What's the width in meters, right? So what is the width in meters means no micro. We don't want micrometers. We don't want nanometers. We don't want kilometers. We want it just in meters. So we're getting rid of the prefix. So here's how I'm going to do it. Step 1, I'm going to write out 44 micrometers. And then I'm going to go to my table. Micro is 10 to the minus 6. So 44 times 10 to the minus 6. There's your micro. Remember, when you're writing it as a number, you do times. So times 10 to the minus 6. And then put the meters in. So 44 micrometers. So that is what we would say is without a prefix, right? I've taken away the prefix. But it's not in scientific notation yet. And the reason it's not in scientific notation is because 44 is not between 1 and 9.999, right? It's got to be a number between 1 and 10, less than 10, but 1 or greater, okay? So you could mathematically, you could say, look, it's got to be less than 10. I shouldn't put X. So the number this number in the front has to be less than 10, and it has to be greater than or equal to 1. So anywhere between 1 and 10, but not including 10. So here's how you deal with this. This is the way I'm going to write it out. I'm going to do one more step. Is I'm going to say, even though when we write a number without a decimal point, we kind of know where it is. It's right there, right? If I say 44, the decimal point is after the 4 on the right. We want to get it to a number between 1 and 10. So that means I have to move the decimal point over one place. We're going to go from here to here. That would give me 4.4. That's between 1 and 10. That's cool. But here's what happens. When you move the decimal point, you change this exponent. Okay? If you move the decimal point, that exponent has to change. Why? Because if I move the decimal point to the left, really what I'm doing is I'm dividing it by 10. 44, if I convert that to 4.4, I'm really dividing it by 10. 44 divided by 10 is 4.4. So if I divide 44 by 10, I have to multiply the 10 to the minus 6 by 10, right? Because if you divide a number by 10, that changes it. But it doesn't change a number to divide it by 10 and then multiply it by 10. That brings it back. So here's how we do it. We're going to move the decimal point one place to the left, and then I'm going to increase the minus 6 by 1. I'm just going to add 1 to it. Minus 6 plus 1 is minus 5. Right? Minus 6 plus 1 is minus 5. And then don't forget the meters. The meters were still in there. So now you have 4.4 times 10 to the minus 5 meters. This fits the requirements of a scientific notation measurement because it's a number between 1 and 10, and it's times 10 to the x, where x is a whole number, right? An integer value. So 4.4 times 10 to the minus 5 meters would be the answer. Now, I remember it this way. If I move the decimal point to the left, so in other words, if I'm moving the decimal point this way to the left, left is positive. And I remember it as lip. Lip, meaning left is positive. So I moved it to the left one space, so I add one number. I add a 1 to that exponent. So the negative 6 becomes negative 5. Okay? The opposite of that is that if you have to move the decimal point to the right, well, it would just be the negative, right? If moving it to the left is positive, moving it to the right is negative. So if I have to move the decimal point this way to the right, then you're gonna subtract numbers there. You would subtract minus. You would subtract 1 there. Okay. Let me show you another example. Like I said, I didn't actually put specifically scientific notation problems in your homework. So I want to show you a couple of these, just so you can practice it. Here we go. Oops, sorry. Sorry for the delay. Here's one. Okay, in this one, this is a chemistry problem. So again, this is interconversion of prefixed and base SI units. In this one, they say you got a physical chemist. So not a biologist, but a physical chemist. Measures the width of a molecule. And the width is 70 NM. Okay. What is the width in meters? And write your answer in scientific notation. Messy. Just make sure that every once in a while I want to check to make sure that, there we go. Yeah, you can see that one, right? Okay, sorry for the scribble of my handwriting. It's not very good, but hopefully you can read that. A physical chemist measures the width of a molecule. The width is 70 nm. What is the width in meters? And then write the answer in scientific notation. Okay, so it's a little bit similar to the previous one. So it's the width of a molecule. So, 70 nanometers is pretty big actually. So maybe it's like, some hydrocarbon, bunch of carbon atoms. $70 nanometers is pretty big, probably like a protein molecule, right? So let me put some oxygens in there. There we go. Okay. So anyways, the width is 70 nanometers. And so that's how big it is. They're just saying that's how big it is. So we just want to get rid of the prefix. So, but then we want to make sure the number's in scientific notation. So here's how we're going to do this. Remember, a measurement has a number and a unit. So that's the number in the unit. Sometimes it has a prefix. So there's the prefix right there. So we look up nano. Nano is 10 to the minus 9. That's nano. So it's 70, 10 to the minus 9, right? So you write 10 times 10 to the minus 9, and then meters. Okay, so 70, that's almost the right answer. In fact, if that last sentence weren't there, write the answer in scientific notation. This would be perfectly fine. If I sent you into a laboratory and you came back and you said it's 70 times 10 to the minus 9 meters, I'd say, perfect, good job. But they want this in scientific notation. So let's go through how we deal with that. Again, you locate, even though it's not shown, the decimal point is after the 0, right? 70, the decimal point is right after the 0. You move the decimal point in the direction such that you get a new number that's between 1 and 10, right? So 70 is not between 1 and 10, but 7.0 is. So that tells you you moved the right direction. You moved it to the left, right? So now here's the tricky part. You got to know your left from your right. Some people have problems with that. So I moved it to the left. And then I'm going to use that, I'm going to use that, what do you call it, mnemonic. Left is positive, lip. So if I moved it to the left, that means I'm going to add a number to the exponent. So I'm going to add 1 to that exponent. Minus 9 plus 1 is minus 8. So you get 7.0 times 10 to the minus 8. And then don't forget the unit. That would be meters. So there's your number and your unit. Remember, a measurement has a number, a unit, and sometimes a prefix. So this particular problem is just all about going from having a prefix to not having a prefix, putting it in scientific notation. And that's not uncommon. Many people will represent measurements without a prefix. They'll just use scientific notation. It's another way of representing the same number. Okay. Let's see. I'm going to look ahead here. Okay, I'm going to look at one more type of problem here. We only have about 6 minutes left. So I want to show you one more type of problem here. And this one's a little bit trickier, a little bit more involved. So this one is called interconversion of prefixed. And I'm going to go through this one kind of quickly. So if I go too fast for you, I'm going to post this onto YouTube in the next couple hours. It should be up on YouTube within the next 2 hours. So you'll be able, you can scroll ahead and watch it again. So in this example, there's a nurse, and the nurse measures the volume of a medicine drop. And the volume of one drop is 0.97 milliliters. Okay. And then they want to know, what is the volume of 100 drops in deciliters? So a different prefix. So deci, D, liters is the volume, right? So DL for deciliters. So a little tricky here. This one's a little bit more involved. So here's what I'm going to do. I'm going to take one drop. So I'm going to say, look, it's 0.97 ml. By the way, nurses are more likely to call ml cc. A cc is the same thing as an ml. It has a different name, but it's really the same unit. So 0.97 ml. And I'm just going to figure out first, what's the volume in 100 drops? So if I have 100, so this is per one drop, right? That's how much one drop is. If I have 100 drops, I'm just going to have 100 times as much. This is going to become 97 milliliters per 100 drops, right? That's all that is. So the first step's easy. You just say, look, one drop's 0.97, so 100 drops is 97. So that makes sense. Okay, now here's the next step. Now there's different approaches to this second part. It's 97 milliliters. They want the answer in deciliters. So they want us to convert milli to deci. And like I said, there's a couple of different ways, at least a couple different ways to do that. So I'm going to show you one way, and by no means is this the only way to do it. What I'm going to do is I'm going to say, okay, 97 milliliters. I'm just going to convert this to liters first. Remember, liters is L. That's a volume unit. So how do I do that? 97 milli is 10 to the minus 3, and then liters. So all I've done there is I've converted it to liters, okay? Now, let me do the following. I'm going to note that deci, which is D, is 10 to the minus 2, right? Go back to that table, 10 to the minus 2. So I'm going to put my decimal point here. And if I move it to the left one place, I now get 9.7, right? Left is positive, lip. So that means you add 1 to the exponent. You add 1, right? Left is positive, so you add 1. So that gives me 9.7 times 10 minus 3 plus 1 is minus 2. And look what you have here. 10 to the minus 2 is deci. So now what I can do is I can say this is deci right here. So that means it's 9.7 deci. Don't forget the liters though, remember? Number, unit, sometimes you have the prefix. So 9.7 deciliters would be our answer right there, okay? So the trick there was to get rid of the prefix they gave you. by just by putting in the number, just put in 10 to the minus 3 for milli. If it had said 97 megaliters, you would just put in 10 to the 6 for mega. Then you move the decimal point until you get the new prefix. Okay, I moved it to the left 1 to make it 10 to the minus 2. That's the new prefix, which is Deci. Okay, so I would recommend just have a little piece of paper, a card stock next to you with the prefixes and their numbers in scientific notation, you know, with the exponential notation. That way you can refer to them very quickly. And then over time, once you do enough of them, you'll memorize a lot of them. You'll memorize like 5 or 6 of them. As you go through Chem 11, you'll memorize a couple more, and then you'll know all the prefixes. Okay. So just a reminder, I am going to post this. This should be up on YouTube in the next couple of hours. 2, by now you should have finished the initial knowledge check on ALEKS, and you should really be working on these homework problems. I forget how many topics I gave you for chapter 1. Let me see here. I gave you 28. So chapter 1 has 28 topics. It's not due until April 4th, so you still got plenty of time. But try to do 2 topics a day, 5 days a week. That'll get you done on time. Better 3 topics a day. And that way, once you're done with all the topics, you can start working on the practice exams. But just don't put it off to the end, because if you put it off to the end, you'll just get overwhelmed. That's true with any course, right? You get overwhelmed at the end. So thanks for being here. We'll meet again next Monday. Again, this will be on YouTube pretty soon. And feel free to reach out, text, WhatsApp, Telegram, or Signal if you have any questions this week, and let me know. Take care, everybody.
Professor?
Yes.
Hi. So I'm okay, so firstly, I'm not able to sign on to ALEKS. I'm not able to register, and I'm not sure why. But also, so is this lecture not at 9 a.m. on Mondays?
Okay, I'm going to stop the recording just so